Hello, everyone, and welcome to this 43rd Urban AI conversation. My name is Hubert, and it's a great pleasure of welcoming you for this new webinar dedicated to the hidden risk of synthetic data for urban AI. So really a kind of critical and important topic. We've kind of covered in a sense, or not covered, but at least discussed a bit. It was during the latest one conversation we had with Stefan Verhulst, dedicated to data winter. So you can have a look. It can also be used as a kind of introduction, in a sense, or complementary insight on this very important topic. And to discuss it, I have the great pleasure of welcoming Yue Lin. Hi, Yue.
Hi, Hubert.
So Yue is assistant professor at the Department of Geography and Geographic Information Science at the University of Illinois, Urbana-Champaign. She's also been actively working and doing research on the social dimension of GeoAI, and also been working on how synthetic data and also tools like ChatGPT are transforming how we approach urban data and how we might, for example, map neighborhoods. I'm not saying too much. I will definitely get Yue share more info during like her 20-minute presentation. As usual, we will first have a 20-minute approximately presentation from our guest speaker, and then we will have a 40 minutes fireside chat. If you have any questions, any reactions, feel free to share it in the chat, and we will react during the entire episode. Yue, the floor is now all yours.
All right, thanks for the introduction, Hubert. And hi, everyone. My name is Yue Lin, and I am currently an assistant professor at the Department of Geography and GI Science at the University of Illinois, Urbana-Champaign. So today I'm happy to share some of my work on and also some of my thoughts on the hidden risk of synthetic data for urban AI. So artificial intelligence has really been paving new ways for analyzing urban environments. We are seeing all kinds of examples, from detecting buildings and land use for imagery, to predicting traffic patterns, to extracting neighborhood features from street view data. In the past 3 years, especially, large language models have taken off, and they can read plans, summarize documents, and even help support planning decisions through idea generations. So basically helping us think through scenarios and even early stage concepts. To enable these AI models to take on more and more complex tasks, over time, these models are becoming larger and larger. So these large AI models really rely on huge amount of data to learn and train. Traditionally, urban data came from things like surveys, censuses, administrative records, or remote sensing. But recently, a lot more of them are coming from the internet. So the internet is full of urban information. For example, Wikipedia has tons of place-based descriptions, books and reports online, and even archive papers talks about cities. And then there is Common Crowd, which scrapes the open web, including travel blogs, newsletters about cities, all kinds of urban content. A rough estimate suggests that about 15% of this massive data set is place-based. So the model can be actually trained to learn spatial and urban knowledge from all of these web tags. So although the internet has a huge amount of urban information, it also carries different forms of biases. One is geographic bias. For example, Wikipedia contributions are largely dominated by the global north, and it has an overrepresentation of these already well-mapped, data-rich areas like North America and Europe. And it's not just geography, there are also gender, racial, and socioeconomic gaps in who contributes content and what gets documented. For example, gender gaps exist in OpenStreetMap, which is one of the most widely used crowdsourced mapping platforms for urban geospatial data. So for OpenStreetMap, editing and tagging are found to be heavily dominated by men. So when AI models are trained on these existing urban data, which are often scraped from the web, they're also learning these same patterns and biases, and that can shape how they understand cities. So our recent work examines how existing biases and representation issues in web scrape urban training data can affect what AI, especially large language models, can produce. So here we look at how ChatGPT describes neighborhood boundaries in Chicago. We found that Southside Chicago, which is predominantly Black, has many gap areas. And this means that a lot of spaces that ChatGPT does not recognize to belong to any neighborhoods. And in contrast, in the north side, where neighborhoods are mostly white, ChatGPT does a better job of assigning spaces to existing neighborhoods. So this likely reflects the unequal geospatial coverage on the internet about cities. So neighborhoods on the north side are more extensively documented, while those on the south side are underrepresented. And these disparities in existing urban web data can translate into differences in how the model understands different parts of a city. So given the many limitations of existing urban data for training AI models, there is growing interest in using synthetic data to complement or augment real-world data and improve model outcomes. So synthetic data can be AI generated, or they can be generated from simple rules, statistical modeling, simulation, or other methods. One example of urban synthetic data comes from urban digital twins, which are virtual representations of cities that can be used to create synthetic urban data for analysis and modeling. So using these kind of synthetic data has the potential to improve AI models' performance by increasing the size of the training samples and supplement rare or hard to obtain observations. And this practice of leveraging AI-generated synthetic data has gained great attention, not just within the scientific community, but beyond. For example, last year, NVIDIA released an open synthetic data generation pipeline to support training large language models. So here's an example of synthetic urban data used to supplement real observations when they are scarce. Specifically, street view images are often used to study urban environments, but most of them are available during the daytime, while nighttime images are pretty rare. Although these nighttime images are also important in informing things like traffic patterns and urban activities. So this work here trains a generative AI model to translate daytime street view images into nighttime and use these synthetic nighttime images to supplement other training data sets. So there's already a lot of work using synthetic data to improve urban models. Here's one example. So this is a study that generates synthetic satellite images of urban areas and uses them to supplement training for building detection. Compared to models trained with no synthetic data, this work is able to detect more detailed structures and also perform better on the outer skirts of the cities. So these areas are where the real labels are usually hard to obtain. So with this kind of potential from synthetic data, there are even forecasts that by 2030, most of the data used to train AI models will come from synthetic sources rather than direct measurements. But is synthetic data actually risk-free? Recently, a lot of research has started to show that synthetic data also has its own limitations. For example, this study compares synthetic urban Airbnb listings in an Italian city, and they found that the spatial patterns lined up well in the urban core, especially the historic centers with already dense Airbnb activities. But in the outer skirts of the city, where Airbnb listings are relatively sparse, the synthetic data generated tends to misrepresent those areas. So, if not carefully examined, synthetic data can embed and even reinforce the biases already existing in the real data. And here is another example of potential limitations or biases in synthetic data production. So, although much of the synthetic data generations aims to supplement situations where real data is rare or hard to obtain, the quality of the synthetic data still depends on the availability of the real data. So here's an example of from earlier where I talked about day to night street view image translation. So again, this is often used when for areas where nighttime images are scarce or hard to obtain. But as you can see from this example, the quality of the synthetic nighttime images still heavily depends on how much daytime images already exist for that location. So in places where daytime images are already limited, the quality of the synthetic nighttime data can still be poor. So again, these kind of biases can still persist. So besides the risk of bias and uneven quality that may be embedded in synthetic data, even if synthetic data appears realistic and high quality, when it begins to dominate model training, there is still a risk of what we call model collapse. So model collapse means that as AI models are trained on synthetic data and keep evolving over generations, they will start to discard low probability features and then eventually produce nonsensical outputs. So the cause of model collapse are coming from several unavoidable sources of error in their generation. So for example, the training data for the model is finite, and the AI models is finite as well, because they need to have finite number of parameters. And also the learning process is usually limited. For example, through the structure biases produced and introduced by stochastic gradient descent. So if synthetic data is used without proper oversight, these inherent limitations may cause the AI to eventually collapse on itself. So this is an example of model collapse we're currently working on in an urban context using street view images. So we can see that as models are recursively trained on model-generated street view images, first objects like cars, people, and trees begins to blur. And then as we increase the number of generations, eventually the entire image becomes unrecognizable. So besides visually demonstrating the effects of model collapse on urban data, we also design a quantitative evaluation. So the assumption of our quantitative evaluation is that if a model-generated synthetic image is realistic enough, then when we use an off-the-shelf and maybe state-of-the-art object detection model to detect objects on this synthetic data and also detect objects on a real image, they should produce similar accuracy. So here we make this kind of comparisons in terms of accuracy in object detection between real image and different kinds of the different generations of synthetic images. So as we can see from these figures, initially the first performance drops occurs for visually small or rare objects, such as bicycles, traffic signs, riders, trucks, etc. But as the generation progress for generate synthetic images, even larger objects like roads and buildings, vegetations, will eventually experience significant drops in detection accuracy, which means that they becomes non-central to human eyes. So some of the takeaways from this talk. First of all, synthetic data can still be useful. So again, many people generate synthetic data to help fill gaps where real data is hard to get, or they're just rare, or when they're limited because of, for example, privacy constraints. Synthetic data can also be useful to just supplement, to provide more training samples, and that training a large model will need. But when we're using synthetic data, it's still important to bear in mind that they have risks. For example, they may inherit and even amplify biases that already present in real data. And also, even if you think you have a perfect synthetic data set for model training, if it becomes the dominant source, it can really distort the long-term model development through model collapse. So training with similarly perfect synthetic data sets over time may still degrade the performance of the model over several generations. All right, so that's the end of my talk. I welcome any more discussions.
Thank you. Thanks a lot, Yue, for the fascinating presentation. Very clear, actually, both on the benefits, but also on the risk of synthetic data for urban AI. It's also super interesting to see that they already have existing risk right now, as are demonstrated your research. Like it's not in the future, but currently happening. I might have maybe a first question regarding biases risk. So you shared the example of Chicago. And so can we explain why is it happening, the fact that by using synthetic data, an AI model might misrepresent a neighborhood or an urban area?
Yeah, so in the Chicago studies, what we did is that we asked ChatGPT to describe the boundaries of different communities in Chicago, because Chicago is known as a city of neighborhoods. So different neighborhoods, they have their different and distinct characteristics. So what we did is that we again asked ChatGPT to describe where they're located. So what we found from our results is that so most of the north side neighborhoods most of the spaces in the north side of the city, which is again mainly mostly white, they are being assigned to a neighborhood, and also the assigned neighborhood also is better aligned with the residents' descriptions of where the neighborhood is. But in the south side, you can see that many of the areas in the south side are being recognized as empty spaces, so they're not being recognized to belong to any neighborhoods in the south side. So one of the potential explanation for this is that because large language models like ChatGPT and others, they are trained based on these online text corpus. So for these wealthier and white north side neighborhoods, they may have more, like, for example, information from Wikipedia or other crowdsourced platforms, or even just discussions in these forums like open forums online. They just have more information provided for this neighborhood that can be used to train AI models. But for the south side, where is mostly Black neighborhoods, and also they have different socioeconomic characteristics from the north, they may not have these kind of rich information on the internet. So AI models may not be able to learn from a lot of data about these different neighborhoods in the south. So that kind of unequal representations existing on the online corpus may be a major reason why we see these different qualities in the cities, in how the model describe a city. And this kind of unequal representation or unequal qualities produced by ChatGPT and other large language models is not just observed here. So previously, there are other research showing how these models generate, qualities like contents of various qualities about other issues. So there was a previous research where some researchers they asked large language models about the environmental justice issues about different counties in the U.S. And they also see that the quality of the responses is also associated with socioeconomic and also race and ethnicity of the makeup of the counties. So so I think the unequal representations on the existing online corpus shaped by these factors, they can persist in what these large language models continues to produce. So
Okay, well, thanks. Sorry, you wanted to add something?
No.
Well, thanks a lot for sharing. Super interesting, especially considering that I know in our audience we have more and more practitioners or even researchers, not only interested, but that are already implementing LLM for urban planning purpose. So that's really quite important to remind the biases that can be embedded in those tools. It's also very interesting to understand that actually those biases, they are existing. So they are part of existing corpus or data set, but they are exacerbating them. What are the solutions? So let's say I'm an urban planner or I'm a researcher, and following this webinar, I'm aware of those biases, but I still want to use ChatGPT or let's say other LLM. What can I do to unbias my results or let's say tools?
I would say the first thing that is important to do is to be aware of the biases. So on that end, I think it's important to develop this kind of critical literacy about AI tools. So when planners are using AI tools like ChatGPT or other large language models, they need to be aware that these kind of biases exist. And I think there are increasing work about how to sort of collaborate with communities when we're using these emerging technologies for planning and urban issues. I think that's something very important to think about. So we don't just rely on what the models tell us about cities, but we want to work more with actual people in the communities to make decisions. So I think, so these would be something we can think about when we want to debias, the way we use the tools.
Okay, so one way is through literacy and kind of individual awareness capacity building. And the second way you said is community engagement. So does it mean like engaging those marginalized communities on recognizing biases, using those AI so that they have a voice? Is it what you mean when you say this? Or
Yeah, exactly. Because when people talk about debiasing these AI model results, a lot of the work are working on first of all, you can debias the training data. You can also use different algorithms to debias how the model learns. So there are lots of work on this, and these can also be very useful. But I think when we talked about bias, is actually really complex, and so if it can't really be addressed by solely rely on these technological advancements, because there are just perspectives and experience that you won't be able to think about as a researcher if you don't talk to the communities about what bias means to them. So I think really talking to communities and who live in the cities, that's important when we think about debiasing.
Okay, very clear. And indeed, quite actually important to recall that we still need to engage those communities and that we cannot maybe speak on their behalf when we want to include or have kind of balanced data sets on them. I have a question. So that might seem weird, but we had a panel, I think it was 1 year ago, with architects from the University of Florida. It was a very interesting panel. And one of the panelists was talking about positive bias. So the fact that, we might use those artificial intelligence, but actually to embed like positive bias, so it can be a way of seeing the world or a way of interacting. So maybe quite close to this idea of aligning models with some cultures. In your field, is it something also you consider and value potentially, this idea of positive bias, or it doesn't make sense in your case?
Could you elaborate a little bit on what positive bias means?
So yeah, that's not my concept actually. So it was really based on this joint conference, but it was this idea of kind of embedding in your AI ways of approaching, contextualizing, or seeing the world, or like potentially on purpose adding more weight on some specific data or some specific elements to better represent it based on your own perception. It can be an individual perception or it can be a collective perception.
Yeah, I think that's I think that's a very interesting thoughts, and I do think, because I come from geography, and I think that also echoes with a lot of thoughts in geography, especially human geography. So although when we're trying to build these AI models, we often say that we want to develop an objective model, right? Or like the way we build other algorithms. But I think these models can also, they are still very helpful if used in a proper way to encourage different ways or even different modes of expression. So like you said, they can be weighted to sort of amplify a weight of thoughts or a weight of looking at things like that. So I think if we recognize the potential of these AI tools in helping individual expression and maybe the expression of communities and populations, and just think of it as a way to express subjective perspective and thoughts, I think that would be a good way to think about the way we use it. Yeah, but I think that's an interesting idea.
Okay, thanks for sharing. You've worked on this concept of post-human geography, isn't it? Can you elaborate maybe on this idea? Like, what do you mean when you're talking and shaping this concept of post-human geography?
Yeah, so post-human geography and cartography, they have essentially they have two layers of meanings. So the first layer is that so geography as a field, or so I'm more specifically in geographic information science. So we are constantly thinking about the relationship between humans and different emerging technologies in the field. So in the past, it was just how we interact with computers, and then we have this big data. So we also think about how we interact with big data, and then we have all these kind of computational algorithms, and then recently we have these AI models. So like the language models and other generative AIs. So for post-human geography, one layers of meaning is to sort of recognize and help people think about this entanglement between human and computers when we're developing knowledge in geography and cartography. And another layers of meaning is more coming from post-humanity. So post-humanity is not just about thinking about like the entanglement between human and machines, but also it encouraged us to think about like what it means to be human. So in the historical discussions about post-humanities, there are also a lot of conversations about how we like how technologies may oppress or marginalize these different communities and populations in the development. So the second layer of meanings for post-human geography is to think about technological developments in geography while also reflecting the impacts on these marginalized and influenced communities and populations. So in the post-human cartography paper, we talked about, so in order to sort of decompose these concepts, we talk about different actors in terms of the way we use AI in geography. So this includes human and non-human actors. So for non-human actors, we talked about training data, AI models, and etc. And we also talk about how these models and how these non-human actors may embed biases and how they may influence different populations differently. We also talk about human actors like the data workers and the shift of roles of cartographers and AI scholars in our field, etc. And again, a major focus of this kind of discussion is like how these kind of changing roles and the introduction of new data into the fields may have different influences on different communities and populations. So, yeah.
Does it mean that do you have in mind the fact that we might create new kind of map, new kind of cartography, or is it related to new relation of powers? Like what? Yeah.
I think that's more reflecting a new way of interactions between humans and machines. So in the past, when humans are collaborating with machines to produce geographic knowledge, it's often just coming between the professionals and the computers, right? So you need to have some existing geographic knowledge to create new knowledge. But with these language models and these popular generative AI tools, they really sort of broaden this access to non-professionals and to a large scale of audience. So a lot of people are trying to use these generative AI models to generate maps, even though they're not professional cartographers. And these new maps are also pouring into the internet, and they may influence the way we collect training data for future models. So yeah, so yeah, we were looking at a new way of interactions here.
Okay, so it's also related to what you shared in your presentation, the fact that non-experts might use LLM to produce their own maps without the right expertise, which might at the end negatively influence models using it as a data input for their training or inference.
Yeah, so that's the risk. So actually for synthetic data, we consider that this kind of synthetic data come from two different sources. One is that researchers may develop methods or models to generate these synthetic data for training like carefully. There's another source which come from mostly public users. So public users may use AI to alter, if not like generate from scratch images or street view images or something else, some other geographic data. And for street view images, there are lots of crowdsourced platforms where users can contribute their contribute street view images taken by their phone or some other devices. So if a user can use AI models to alter street view images and then upload to these crowdsourced platforms, then these images may contribute to future model trainings because those crowdsourced street view image platforms are exactly where researchers collect those training data from. So there might be a feedback loop if that can negatively impact the performance of the models long term. So,
do we have way of preventing from this?
Yeah, so I think so again, the first thing is to still develop that AI literacy. So in this sense, it's important for the platform to recognize the impacts of synthetic data on the future use of their data. So if they have this kind of awareness, there are multiple ways to, if not prevent the pouring of synthetic data, but one popular way is that you can label whether an image is AI altered or AI generated on their platforms to help researchers distinguish between authentic image and otherwise. So that would already be a really useful method to just add something in the metadata and help researchers to distinguish between these two kinds of sources. But again, to be able to do this, so AI literacy is very important because if you don't recognize this kind of impacts, you don't know how important this is.
Okay, very interesting. So by labeling those synthetic data, maybe also you said it in the beginning when you were talking about literacy, and I recently saw like a journalist school that was integrated to their module learning training sessions to recognize some AI generated content, visuals, writing. So that could also be a way to better map, understand, or recognize at least those synthetic data.
Yeah, there are models that can be used to distinguish between AI author and non-AI author images. So that's a way. So there are multiple routes, right? You can also ask users whether you use any AI tools to edit your image when they're uploading the image. And then you can also use AI, use algorithms and models to sort of classify whether this image is AI edited or not. There are different ways to create those labels in the metadata. But I think, well, at least as far as I know, most of the crowdsourced platforms that provide this kind of data still do not have this feature.
Okay. Do you envision like a kind of new way of producing a map or geographic map? Like, do you believe you first shared the fact that initially you had a kind of very simple relationship between human and computer, and that's now you're having kind of more stakeholders, more workers. Do you believe it will like kind of strongly, powerfully change how geographers are creating maps, basically?
Yeah, I think AI is already it is on its way to change how we create maps. But so there are a lot of people that try to use prompts. They try to prompt generative AI models to generate different kinds of maps. Um, but so the thing with the current generative AI models is that if you just simply input this kind of prompts, the maps that are being generated is just not it's not usable at all. I don't know if in the future these models will continue to evolve and enable people to create better maps. But as for now, so if you're using the map for for publishing or just for putting it in your own websites, things like that for a practical purpose, and generative AI is still not a very good tool. But I think generative AI or these AI agents, they have been so there are also researchers talking about how to make use of these AI agents to automate, modules and in terms of how we create maps. So in the past, we usually have these cartographers. So they use software or programming to sort of create different components of maps and put them together. But there are recent work demonstrating how we can sort of augment or even replace the roles of cartographers by using AI agents. So if you are able to develop a reasonable workflow and decompose the task into things that large language models can do, then ideally you should be able to just create maps by using these AI agents to call different functions or to retrieve data using APIs and so on. But developing such a workflow using AI agents is possible, but it's still a lot of work. But that's a potential thing that may happen in the future.
Okay, so here the goal is to facilitate the creation of map through AI technologies, including AI agents, like producing faster, more efficiently map.
Yeah, and another thing about using AI agents is that so in the past, when cartographers are creating maps, the cartographers do have a lot of professional knowledge and they know where to put different things. And they also know where to get data. They know the website and know the API and so on. But for a public user, if you don't have those kind of domain knowledge, it's a lot of self-learning. But with this AI agent, I think a potential is that they can read human language. So if you have a prompt, you can just tell the agent or the agent system what you want the map to look like in plain language, non-technical language. Then with a well-developed workflow, then it's gonna be able to create a map for you, ideally. So in other words, you don't need to really know where to get the data. You don't need to know where to put everything on a map. You just describe what kind of map you want. And then ideally, this kind of system should produce something reasonable for you.
Okay, so it's lowering the technical barrier to manipulate and use map.
Yeah.
Do you see a kind of geopolitical, are you aware of geopolitical risks by the use of AI for map creation? Like, are there already, I don't know, some communities, countries that have been using it, for their own interest or maybe to claim, their own borders in a sense?
Yeah, I think So one risk that I'm aware of is called deepfake geography. Um, so well, traditionally we use satellite images as ground truths, because we think that these satellite images, they are taken from above and they just reflect what they see. But with these generative AI models, there's a risk of, again, modifying or editing these existing satellite images to a view that doesn't really reflect the truth. So these kind of deepfake geography, they can create misinformation, and like you said, they may be used to sort of they may be used for propaganda or some kind of deception, things like that. And another thing about the risk here is that, again, many geographic information or urban information on the internet, they're unequal. So their representation is not equal. And if you want to use AI models to being trained on these data sets, so the way they describe places will not be equal. And so for geopolitically, you will see that they may describe some places that align with what the residents or what the people there think, but for other places, they may just create a lot of distortion about, especially for places that do not have a lot of good contents, or may not have a lot of well-documented contents on the internet. So so there's a risk on that end as well.
Okay, so that's very interesting to see, in a sense, a kind of dark side, negative side of also this AI augmented map. We saw the good side, which is like lowering technical barriers, so new communities can do it. Also, experts can do it faster. But as you're showing, they might also have kind of negative or dark side, in a sense. You also mentioned, which was fascinating, the collapse model risk, and also at the urban level, what it looks like. So it's actually a fascinating result. It means that kind of necessarily, if we repeatedly train an AI with synthetic data, the end result necessarily, that was showing your graph, is that the collapse will basically model a collapse.
Yeah. So and that's also a risk we talked about in the context of Street View images. So again, most of the crowdsourced platform, they're maybe not there to create these labels to distinguish between AI edited or AI generated images, between these real user taken images. So we demonstrate this example in this context because if so in a hypothetical scenario, if a lot of images from these crowdsourced Street View image platforms are synthetic, and if they are just being used to train AI models recursively, then there is a risk of just producing nonsensical results at the end over multiple generations. And that can generate to other scenarios beyond just Street View images. So one example is that OpenStreetMap, which is still also a crowdsourced platforms. It relies on users to sort of draw the polygons of buildings and contribute to information like this. But so right now in OpenStreetMap, there are new ways of contributing data by just using model predicted labels. So that's another form of synthetic data, I would say. Maybe not quite as the Street View images, but if we define synthetic data as model generated data, then they can be thought of as synthetic data. And so we also think we also want to sort of highlight the risk of that, because those data should also undergone quality checks and also should be used with caution. So
what are the solutions then? You showed this very striking graph where it's like estimated that in 2030, like most of the available data on the web might be synthetic data. So like with what you said, it's especially important. At the institutional level, we kind of discussed kind of possible solution. It was with Stefan Verhulst from NYU webinar. So a few weeks ago, if you're interested to have a look, feel free to do it. It's available on our YouTube channel. But we didn't explore, in a sense, like, let's say, the individual possibility solutions. So let's say as an urban planner, geographer, what can I do to have the kind of like leveraging synthetic data without collapsing my models?
I think an effective way to prevent model collapse is to always have is to prevent your training data to be dominated by synthetic data. So if you have a fair amount of real data in your training data sets, I think the impact of synthetic data can be sort of controlled, or it can be minimal or even beneficial. So that's so there are lots of works on how much real data you need in your training data to keep your model training effective. Yeah, so I think that would be a very simple and effective way to prevent model collapse.
Okay, so as an individual, being sure that, let's say, in your total amount of input data, you still have a significant one dedicated, like, which are real data, and using like the synthetic one just maybe to complement marginally. But okay, very clear.
Yeah, but I think that kind of solution also would need a institutional or like a higher level support, because as the general public has a lot of this access to generative AI platforms, so a lot of the images or data or even Wikipedia entries that you see online, they may be created by AI models. So what I mean by institutional efforts is that these platforms, online platforms, or data providers, they need to have a way to sort of label whether these content or that content is model generated or model edited versus contributed by users by themselves. So if we don't really have that kind of labels, it's really hard for individuals to distinguish which part of the training data is synthetic, which part is not. So yeah.
Okay, so yeah, there still is this need for like institutional support, being able indeed like label which data are synthetic and which are not. Okay. Maybe last question, because I see the time is flying. What make you the most, let's say, enthusiast like about the potential of AI in geography and cartography in the next years?
So I would say I'm mostly looking at this kind of social impacts of AI and how these new technologies may influence different communities and populations. So if you ask me, I would be interested in seeing how these AI methods can be integrated with what we already have in geography. So in geography, we have a strong emphasis on the human-centered methods and human-centered research. But with AI coming into place, it's often shifting into a machine-centered way of looking at things. So I am sort of interested in seeing how these two kinds of way of looking at, or these two kinds of ways of seeing can be integrated or combined or even enhanced when they're being put together. So, yeah.
You said, yeah, we have a question indeed on YouTube. I'm not sure also to have well understood. You said meter-made? No, center. What was you used the word? You said center matching.
Can you elaborate that a little bit?
Yeah, no, I think I'm not sure. I think it's the question is referring to one of the words you used, but which maybe wasn't clear. And I think it was when you were describing the integration between human and machine. You talked about center matching. No, maybe not.
Yeah, so I was sort of I think what I was saying is that I was just interested in how these AI methods may be used in a human-centered way. So how we will be able to integrate, again, this experience and perspectives from humans in the use and or development of the AI methods. So
okay. Very clear. And I think in a sense, like the whole presentation and all discussions is also going toward this direction when you were really discussing like the positive effects, possible positive effects of interconnection between human machines and also like communities. Well, thanks a lot, really, Yue, for this fascinating presentation that was very clear. That was also like very insightful. Like you provided several very concrete insights. Like if you are an individual and that you are looking like to integrate LLM into your project, so like okay, how you can minimize biases or how you can avoid, in a sense, collapse models. So really, thanks a lot for this. Thanks also for joining despite Thanksgiving. So really appreciate it. That's already the end of this Urban AI conversation. We will see again next week, and it will be this time with Emily Royal, who is Smart City Director at the City of San Antonio. She's also a member of the Urban AI Board. And in the meantime, take care, everyone. And if you are celebrating Thanksgiving, have a wonderful Thanksgiving.
Great.
Thanks, you.